Good afternoon, students. Am I audible? Okay. So already a circular is forwarded on our group. So be serious about the examination because here online examination might be conducted for 2021 academic year, and hence it will not consider that whether how was your performance, how much syllabus has been covered. Whatever the syllabus declared by the university, the same syllabus will be covered for the examination. So be serious about the examinations. If you are absent for any of the classes earlier, already I have shared an Excel sheet with you where all the lecture links are available. So please go through the lectures and attend those lectures carefully, and be serious about your examination. As yes, classroom teaching cannot be replaced by the online teaching, but you must try to take things very seriously. This was the very first issue which I wanted to discuss regarding examination. And how many of you yet had not applied for the examination of backlogs? Please let me know. How many of you still had not applied for the backlog examinations? Anyone is remaining who yet had not applied for the backlog examinations? Okay. So here, uh, if considered you had not applied for the uh, backlog classes, then along with the examination of 2021 first semester, you can apply for the backlog examination. That was the thing which I wanted to make you sure. And here, I had not seen anybody uploading the registration details regarding uh, IIC projects, that is the MHRD Innovation Cell. Have you registered for that site? Are you listening to the videos, applying for the quiz? How many of you are attending IIC sessions? Yes. Please, those who have registered, raise your hands or can reply yes in the chat window. Only single student have registered for the IIC, Maharashtra Innovation Cell. Only two, three. At the end of this series, lecture series, there will be a certificate generated for registered users, and there it will also mention how many sessions you have attended. Okay, so it means along with the attending the session, you also have to apply for the quiz, and all quiz, it means rank will be released to your account, but on the certificate it will give how many sessions you have attended and whose sessions quiz you have passed. Okay, so I request all the students that you frequently check the list. Those sessions which you have missed can see onto the YouTube, as well as you can reappear for the test also. So as AICT number of users have requested to reopen the test links, so frequently please check. As soon as I will also, it means I'm also going to check the reopening of the test links, assessment test link. As soon as it will be open, the same message will be conveyed to you, and you have to appear for the test via your registered email IDs. So okay, here those sessions are important because here whatever they are sharing, that is a global knowledge and related to innovations are there, and this will help you to select a domain regarding the final year projects, and this is much more useful, and that's why it means this activity is also made compulsory to the students also. Okay, and it is mandatory for you to apply for those certificates. That is mandatory. It means each and every student must apply for that certification. Okay, so soon I will make you phone calls regarding the upload appear for that registration, and if not, please hurry up. So this is my final call to you regarding the uh, asking for the Maharashtra Universal registration. Okay, this was the second thing. Third thing, today we are having honorable principal sessions at 6:30 p.m. on the Facebook Live. So I request all the students to please attend that live session. Okay, and please convey this message if anyone near to you, that relatives etc., who is having appearing 12th student, past 12th student, and willing to appear for the graduation in engineering, then you can suggest them to apply, watch that Facebook live session. So now that's it from today my side. Let us start with the lecture. So anyone is willing to ask any of the queries, any of the confusion, etc. If no problem, then we can continue with the lecture. I didn't ask to enter your roll number. I previously also told you that I'm having auto mechanism. Whenever I'm explicitly asking you to give your roll number, then only you should give your roll number. Okay? Instructions part is over. Lecture part yet to. So in the last lecture, we have started with the chapter 6. Am I audible clearly? Okay, in between I'm facing the mic problem, that's why I'm leaving the meeting. Please do not leave the meeting if even though I'm out of the meeting, still within a minute or two, I will rejoin the meeting. Voice is breaking. Okay, let me check for a minute.
Am I clearly audible?
Am I clearly audible?
Now?
Ma'am, your voice is getting
Yes,
repeated.
actually, I kept on mobile voice as well as machine voice. Now it will not be a problem. Now check whether it's still echo is there. No echo. So here we have started with the properties of the transaction. Atomicity stands for either all operations of the transaction should be completed, that is, its effect should be shown on the database, or database should be in the state that none of the statements from my transaction has been executed. That, for example, for executing any of the transaction, if I am executing the 5 statements, then a transaction should be at the level 1, that is, all the 5 statements are having its effect on the database, or it should be at the level before executing the first statement or all statements from a database, from the transaction. Okay, atomicity either full or null. Okay, that is the meaning, and that's why the name is given atom. It means that this stands for the indivisible unit. We cannot divide transaction into multiple subparts. Even though if consider there are 5 steps, now I executed 3 steps and tomorrow I will execute for the 2 steps. No, here a division of the task cannot be done. And that's why the first property is renamed as atomicity. Next is the consistency. Consistency, it means that this should be a correct database operation should be going on. That is, this is mixed with the explanation of isolation. That is, it might happen that we simultaneously, it means multiple users are going to access database simultaneously. So in that case, here, if both are executing the transaction on the same data item, then everyone of it means 1 or 2 or whatever it may be, they should feel that they are the only users which are performing transactions on a database. That is, each one should be isolated from another. And consistency, it means that my database should be in the state that all these operations, that is simultaneous access, result into a serial execution. That is, if consider there are 2 users, user 1 and user 2 is there. Then in that case, user 2 should feel that I'm the only one who is accessing the database. User 1 should always feel that I'm the only one who is using that transaction or using that data item. And after completion of both of the transactions, database should be in the state that either the sequence of execution is user 1 executed first transaction and user 2 executed secondly, or user 2 executed initially and then user 1 executed next. So it means that even though anyhow if I am performing the operation, the data item should have correct data values. Okay, for this purpose, we have taken the example of a withdrawal of money from our account. That is, if two are trying to read the same data item and performing some update operation, then how it can be differentiated. So that was the meaning of consistency. Consistency, it means that database should be having a correct data value. That is the meaning. Next, isolation, that if two or more users are trying to access the same data item, they should be isolated. They should not be overlapping, or it means there should not be here and there of the data items. Yes, concurrent access is allowed, but at a single point of time, only single user can use that data item. Okay, that was the meaning of isolation. And durability, it means that after a transaction completes successfully, the changes should be available into a database. Okay, whatever the changes, considered data transaction T1 has made that previously A's balance was 10,000 and now 1 is credited, and that's why the balance is 11,000. So it means that that effect of transaction should be there on the database. Consider that after completing the transaction, power goes off. Then after resume of my database, it should show me the value as 11,000 only, not 10,000. That whatever the effect of that transaction is there, that should be persistent, that should be permanent. Okay, that is the meaning of durability. So, and that's why by taking the first letter from each of the properties, these properties are called as a acid property. Our complete chapter is based on this acid properties only. So if you are clear with the four properties, we can move to the next point. Any doubt in these four properties? Whether my voice is clear to you? Clearly you can listen me? Okay. So let us move to the next point. A simple transaction model. So already in the last lecture also we have started with this point. So simple transaction model, it means that in this point we are going to take an example and how that example will be converted as a transaction, that we are going to see. So here, whenever we are performing a database operation, up to now we have studied many queries about the database, that DDL queries are there, DML queries are there, and within the DDL again we are having subtypes as, that is create, alter, or drop table, and here in the DML we are having insert, update, delete, and select queries. But here the main difference between transaction and DML queries is that DML queries will perform operations in 4 terms, that insert, update, delete, and select. But in case of transaction, there are only 2 types of the operations are there, read and write. Okay, read, it means that this is a select operation where we are reading data from the database, and whatever data we are writing, that the same name is given to the read X operation. So it means that read X, it means that we are reading data from X from the database. Okay, so read, it means that you cannot perform any changes to that X member. Okay, next is a write X operation. Write X operation means that you are performing or updating the value of that X. Previously, X may be having any value, but write X, it means that whatever the value held by that local variable X is there, that you are making permanent to the database. Okay, database is a secondary storage because this is a large database, and whenever we are accessing the database, those will be brought into main memory. But whenever we are performing the write X operation from the main memory, whatever may be the value of that local variable is there, which is available into primary memory, that new value or that changed value is written to the database. It means that is written to the storage. Okay, so that storage will remain permanent storage, and that is a permanent change to my value X, unless and until another write operation is performed on that. Okay, so here read X and write X. Now forget about the concept insert, update, delete, etc. Insert it means that writing the new value, delete it means that removing the value, and update again it means the writing of a new value. Okay, so let us read this explanation. Transactions access data using two operations, that is read X, which transfers data item from the database to a variable, also called X, in the buffer in main memory belonging to transaction that executed the read operation. So, okay, it means that whatever the database values are there or data variables are there, those will be brought into memory. It means that there will be a copy created into a buffer in the main memory, and changes will be performed on those variables or those value set, and those will be returned back to the main database. Okay, so unless and until we perform the write operation, those changes will not be reflected to the right database. Okay, so next, write X operation, which transfers the value in the variable X in the main memory buffer of the transaction that executes the write to the data item X in the database. So it means that here we are performing changes to the database. So here this is a simple transaction where we are transferring that is the amount of 50 from account A to account B. Okay, so here for this purpose we need to perform these operations. Consider that whatever the operation we are performing or transaction we are performing, to that we have given the name as TI. TI stands for the transaction name. Then if we wanted to transfer money from account A to account B, first we will read a value A. First we will read a value A from the database. Then we'll perform changes to that value. So here whatever A equal to A minus 50 is there. So here read A will create a local copy into main memory. Okay. Another copy of variable A, that is a data item account balance, into buffer in the main memory will deduct 50 from that value only. So these both of statement does not perform any changes to the main database. Okay. These are simply the operations which are carried out into main memory. Then after deducting the 50 from A, now A is having the new value. That new value we can write to the database by using write A operation. Now this step will result into changes to my database. Next, read the another data member B, perform the changes, that is add this 50 to the B, and then write the B. That this operation also will result into changes to my database. And hence there are only, out of 6, there are only 2 statements which have actually performed changes to the database. Write A and write B. Only these 2 will result into changes into database. Clear with this operation? Clear with this operation? So, okay, now let us move to the next point. Now, with this particular example, how we can say that we have achieved the acid property? Okay, that was the main point. So here, consistency, we wanted to check here. So for checking the consistency, consider that as balance is getting transferred from A to B, we can say that whether my transaction is correctly performing work, that we can say that sum before the transfer of 50 and after the transfer of 50 will be same, as 50 will be deducted from A and that same will be added to the B. So whatever the addition of A and B before the transaction is there, the same will be there after the transaction. Then we can say that yes, our transaction has kept our database into consistent state. So for this particular example, consider that we are having A value as 1000 and B value as 2000. Before the deduction of 50, both will have the summation to 3000. And after performing all the statements, that 6 statement, read A minus 50 and write A, read B plus 50 and write B. So these will make result A equal to A minus 50, 950 will be there, and B equal to B plus 50, 1000 and 50 will 2050 will be there. And hence addition of these two will again give the calculation as 3000. So, okay, that was the main concept, that here we have achieved the consistency. Next, atomicity. So atomicity, it means that there are total 6 statements are there, and either database should be in the state that A equal to 1000 is there and B equal to 2000, that was the initial state, and or it should be at the state that A equal to 950 and B equal to 2050. Okay, so it means either database should be before this statement execution, whatever the state it was, or it should be after this statement execution. Okay, so the same is explained here. So just before the execution of the transaction Ti, the values of accounts A and B are $1,000 and $2,000 respectively. So now suppose that during the execution of transaction Ti, a failure occurs that prevents Ti from completing its execution successfully. Okay, then the database will remain into inconsistent state. Ensuring atomicity is the responsibility of recovery system. Okay, so in the main architecture we have seen recovery manager also, so that takes care of recovery system. So we will see these components in the next coming chapters also. But right now, keep in mind that atomicity can be achieved, that is, maintaining the atomicity is the responsibility of recovery system. Next, durability, that once that whatever the changes we have done, 950 and 2050, that should be accessible to the next transaction, or should be there even though there is a system crash immediately after the transaction. Still, we will be able to see that yes, A is having the new value as $950 and B is having the value as 2050 as a new value. So here, this might happen that we have executed the transaction, that whatever the 6 statements previously we have executed, that all statements we have executed, and before performing changes, that write B is executing. At this point only, we got a system failure because of any reason, any hardware or software problem. So it means that here, this is not, there is no guarantee or way to check whether those changes are done to the secondary storage or the actual database. Okay. For this purpose, it means we are maintaining this track by using two statements, two ways. So the first one is, it means whether my changes are permanent or not. That can be checked by two options. First one is that whenever we are performing updates to the transaction, we can write to the disk before the transaction completes. It means maybe transaction is reaching to the end state, and before that only we should perform changes to the database. That is first solution. And second one is that, so whatever the information, that information about the updates carried out by that transaction and return to the disk is sufficient to enable database to reconstruct the updates when database system is restarted after the failures. So it means that here, whenever we are having the existing state, then it might be helpful that yes, whatever state it is a consistent state. That also can be a solution. So here, both of these options are costlier because here multiple write operations are required. So here, if consider that previously I have executed this statement that write B. Write B, it means that we are writing the new value of B to the disk. That update operation, we can take help in order to know that yes, this operation was incomplete and that operation we can carry it out and can complete the transaction. That can be also a way to ensure the recoverability. Next, isolation. So during the execution of my transaction, okay, so if during the execution of our transaction, if it means T1 transaction is executing and T1 transaction is accessing A and B in update mode or write mode, then other transaction T2 simultaneously should not be allowed to perform any read or write operation on the A or B. Okay, that is the meaning. So isolation can result into inconsistent state, and because of which whatever the results are there, that may not be a correct result. So for this purpose, we can, it means there are many ways to do this. So we can do this by keeping a log, etc. So here the explanation says that consider the database is temporarily inconsistent while transaction to transfer funds from A to B is executing, that we are transferring 50 from A to B, while the deducted total returned to A, that A's new value is written, and increased total yet to be returned to B. B's new value 2050 is yet not returned to the disk. If a second concurrently running transaction reads, okay, there is a transaction T2 which want to transfer or which may be willing to read data items A and B. At this intermediate point, it means in between a transaction, will compute A plus B. Okay, A plus B will be computed by the second transaction. So 950 plus 2000, that will be 2950. Okay, it will observe as an inconsistent state. So during the execution of intermediate state, if any other transaction is reading all the data items, then that can be also a problem, and hence database will not be into a consistent state. Okay, and for this purpose, we keep transactions isolated. Isolated, it means that if T1 is performing any changes to A and B, simultaneously T2 will not get executed. If T1 is not using C and D, then T2 can use. Those data members which are not common in both, they can be used by any number of the transactions. And hence, we have achieved the isolation also. Next, storage structure. So, storage structure, here we have seen the three types of the storage structures: volatile, non-volatile, and stable storage structure. Volatile, it means that after the crash, the data doesn't get saved, so data will be lost. And in non-volatile, even though there is some system crash, etc., still, or power failure, etc., still it preserves the data. And last one is a stable storage. Stable storage, it means that the data in the stable storage is never lost. Never lost, which stands for this keeps a data in any kinds of the failure. So stable storage is a theoretical concept. It means there is no any memory that which cannot have any type of the crash, etc., or no any physical device or no any electronic device that cannot be it means cannot be destroyed. Here, the stable storage concept, it means that we are referring that whatever the data is available, that will not be lost. It means even though the chip in which the data got stored that is broken, still there are ways to recover that data. That is by keeping the backup or by keeping the multiple copies, etc. So that is meant by a stable storage. Transaction atomicity and durability. So here, before moving to this point, that transaction atomicity and durability, first let us see which are the stages of a transaction are there. Okay, so there are total 5 stages of the transaction are there. So whenever a transaction is complete means that it is in the all the statements have been executed. Then we can say that the transaction has entered into committed state. Okay, so let me show you the figure. So this is the state diagram of a transaction. So here, whenever any transaction entered after the begin transaction statement, okay, we know that there are 2 statements which are deciding the starting and end of the transaction. So begin transaction, it means that at least first statement is getting executed and yet it had not executed the end transaction statement. Okay, whenever a processor is executing either statement between begin transaction and end transaction, at that point the transaction will be called into active state. That either it is executing a single instruction from the transaction. Next, whenever it reaches to the end transaction statement, yet it is not executed. When it completes all the execution of all the statements into transaction, then it will enter into partially committed state. Committed, it means that just like saving for the permanent. Commit, it means saving the data. When it completes execution of all the statements, these changes will be temporary into a local, into main memory. These changes yet had not reflected onto a database. Okay, whenever partially committed state is there, yet it is in the transaction only and has completed execution of all the statements. And when it reaches to the committed state, it means that along with the executing all the instructions, it has performed changes to the database also. Okay, committed, it means that it has performed all the changes to the database. But if consider before the going or performing changes to the database, if any problem occurs, then the data transaction can go into failed state also. Failed state where it means that here it had not performed any changes to the actual database. And hence, if there is any statements which is getting not executed or facing any hardware or software problem, Then from active state, it can also go to the failed state. It means there are five statements are there, where reading the data of item from A, performing the deduction of 50, and then adding to the B. If consider that A doesn't have sufficient balance, that it is having amount as 49, then in that case, there is some logical error because of which we cannot continue with the transaction, and hence such transactions will be also become a failed transaction, and hence whenever it is reaching into failed, that transaction will be forcefully terminated, or which is also called as the aborted state. Okay, so these are the five states of the transaction are there: active, partially committed. From partially committed, it can go to committed state, or it can go to the failed state, and after the failed state, it will reach to the aborted state. So here, whatever committed and aborted state are there, these two are the final steps of a transaction. Okay, and hence any transaction which is in committed or aborted state, that will be called as a terminated transaction. So if we are at the failed state, so now what should be done at this stage? What it should do whenever it is in the failed state? Here, it might possible that it means there are different ways to continue with the transaction. Okay, so this might happen that some transaction perform changes to database after every write operation. Some databases or some transactions allow write only at once after the completion of transaction. It means that any possibility can be there. So if consider that during the transaction execution, if any of the transaction has performed changes to the database, and at this stage, whatever the remaining statements of the transaction are there, that cannot be executed. So in that case, here it will go for rollbacking the changes. Rollback, it means that undo the effect of previous statements. Undo the effect of previous statements. So if consider A's new value is 950, and that change we have done to the database, and when we begin to add value to the B, because of some problem, transaction cannot be reached to the committed state. It has reached to the failed state. Then for correcting this transaction, we cannot keep database into incorrect or inconsistent state. So in that case, whatever the changes we have done to the A, that deducting 50 and adding the new value, we can undo these steps by adding 50 to the current value and writing the new value. So okay, rollback, it means that undo the effect of previous statements or undoing the database operation. So that is one way to go through the transaction, and that is a transaction whenever transaction is failed. So that is one way. Or another is that we can maintain a log. Log, it means that this is a record which keeps a track of changes to the database. So then we can maintain a log also. So log will be having an entry that T1 transaction has written A's new value, but it not committed. So this will also maintain a log that which transaction has been committed and which is not yet committed or terminated. So those transactions which are having start or begin as well as commit, those will be completed transaction, and those who have only start but no commit, no abort, no failed, those transactions will be terminated. Okay, so here Log refers to each database modification made by a transaction is first recorded into a log, that is a file where these changes are preserved. A transaction that completes its execution successfully is said to be committed. That along with the performing the all operations, it has performed changes to the database also. Then the transaction will be called as a committed transaction. The only way to undo the effect of committing transaction is to execute a compensating transaction. So previously I mentioned that a equal to a minus 50. This operation we have done, then we will do exactly reverse operation, that a equal to a plus 50. So compensate the effect of previous wrong statement. That also can be done. So transaction is always in one of the following states. First, active, that initial stage, a transaction stage in this state while it is executing any of the statements. Partially committed, after the final statement has been executed. If there are 5 statements into a transaction, all of the 5 we have executed. Next, failed state, that whatever the normal execution is there, if transaction cannot continue with the current execution, then that transaction will be called as a failed transaction. Next, aborted transaction. After a transaction has been rolled back, the database has to be restored to its state prior to the state of transaction. It means either zero or null was there. Sorry, zero or null. It means intermediate state to the coming to the zero. Before the start of transaction, whatever the database state was there, reaching up to that, that will be called as a aborted. And next is a committed. Committed, it means that after successful completion of a transaction, successful completion, all the operations also are performed and also the changes are carried out to the database, written to the log, etc. So, okay, this all operations will declare that yes, a transaction has been completed successfully. So, okay, please go through this figure once. See, now let us move to the next point. So here, whenever there is a abort of a transaction is there, then it might happen that we may be willing to perform that transaction anyhow. So it means that there are 2 ways to recover that transaction. So it means transaction might enter into failed state because of any reason. But how to recorrect that transaction, that can be decided. So, okay, it means there are 2 ways to tackle this problem. The first one is restarting the transaction. Restarting the transaction, it means that whatever transaction we have started previously, which was aborted because of some logical software or hardware problem, not logical, software or hardware problem, that server got failed or machine got off or any device is not working, which is required for performing that transaction. In such cases, we can go for restarting the transaction, but here a new transaction number will be given to that transaction. Okay, here this will be restarted as a completely new transaction. Okay, There will not be any previous steps, etc. It means that there is any no relevance that previous transaction only we have restarted. No, there will not be any relevance. Here, if there is any hardware or software problem, then only we can go for restarting the transaction. And if consider a transaction is failed because of some logical problem just like I am a C user and trying to read a data item A and trying to perform changes to A. Then in that case, there is a logical problem with access of A, or A doesn't have sufficient balance, or consider that A is having 1000, but the requirement of bank is that it should have a minimum balance 1000 and hence A cannot withdraw money. It means that such logical problems also can be there in that transaction. Okay. So in such cases, we cannot continue with the transaction and hence in that case, there is only one option that we should go for killing the transaction or kill that transaction. Okay, so in this case, unless and until A's balance become more than 1050, we cannot go for deducting the 50 from A's account. Okay, so wherever there is a logical problem is there, we cannot continue with the transaction anymore. So in that case, a transaction is better to kill that transaction. If any other software or hardware problem is there, then we can go for restarting that transaction. Clear with this? So, okay, remaining points we'll see tomorrow. Please don't forget to attend the Facebook live session at 6:30 and please appear for the quiz by IIC Maharashtra Innovation Cell. We will stop here today.